Okay, we have the system AX equals B. To solve the system, we multiply both sides of the matrix on the left by A inverse. Now, we worked through two examples of this last time. One example in much detail, another example kind of quickly at the end. It's all in the videos, so you've already seen it. So you should already be familiar with it and have an idea where it goes, but if you don't, well, you'll see here and you can go back and look at those videos. Okay, so we have A inverse times this. So we multiply this by A inverse, we get A inverse times this. And we do the same here. A inverse times B, well, there's A inverse times B. Okay. Now, we've just claimed that any time you multiply a matrix by its inverse, you get the identity. Now, there's more to prove here, but that's something we're just going to take as something we understand. So if you multiply the matrix by its inverse, either way, A times A inverse or A inverse times A, it's going to give you the identity. So instead of A inverse A, we write identity times X. Now, the identity has a very special property. If you multiply the identity by any matrix, now you can't multiply this identity by just any matrix. It would have to be a matrix that has two rows. So each column has two elements, so that you can multiply it by a row that has two elements. Anytime you do that, you're going to get the same thing. Just like multiplying 1 by x always gives you x, multiplying the I matrix by any matrix that's compatible with it on multiplication gives you x. And we demonstrated that. I asked people to do I times the column aardvark anthill. Well, some people didn't know what to do with the aardvark or the anthill, but once people saw it, it became pretty clear. And this is in part, in some cases, because people still don't get this multiply row by column thing. Now, this is 9 days old. We need to get this. We multiply 1, 0, the row 1, 0 by the column aardvark anthill. We get 1 times aardvark plus 0 times anthill. There it is. And we multiply, and it's a little hard to read there, but you understand what you're saying. If you multiply the row 0, 1 by aardvark anthill, you get aardvark. Sorry, that's 0 times aardvark. I can't read my own handwriting, and nobody else can either. 0 times aardvark plus 1 times anthill. Okay, well, what's 1 times aardvark plus 0 times anthill? It's just aardvark. What's 0 times aardvark plus 1 times anthill? Well, it's just anthill. So we did the identity matrix times the column vector aardvark anthill, worked through the details, and found that the result is aardvark anthill. Okay, well, there we have it. Just one example. And we could prove it, but you can also accept it. Anytime this matrix is multiplied by another matrix that's compatible for multiplication, you get that other matrix. It's the identity. It's an identity element. It doesn't change what it operates on. Okay, so the identity matrix times the x column vector is just the x column vector. Now, aardvark anthill, that could be our x vector. Okay. Our x vector will be like this. It'll have some number here and some number here. Whatever those numbers are, when you multiply it by I, it's going to give you the same thing. And if these numbers are variable unknown numbers, xy, I times xy would be xy, just like I times aardvark anthill is aardvark anthill. Okay, so the xy column, that's what the x vector is, multiplied by the I gives you the xy column again. Now on the other side we have A inverse times B. Well, A inverse is just a perfectly happy innocent matrix. You just multiply it by your B vector by this thing, and you get two numbers. And you have your solution. So it's just a very brief process, okay? Now, before you can do this, you have to have A inverse. Okay, well, I'm going into more detail than I should need to, and I don't mind doing that. It's just that it makes the video a little bit longer for people that already know what they're supposed to know. So if you already know how to get that inverse, and if you've already been able to write down, if you can write down without looking, write down the steps and write down the inverse of A, and if you get the right answer, you don't need to watch me do it, okay? I'm just following the rule. What's A inverse? It's what you get when you flip the diagonal here and negate, make negatives on the diagonal there. So if you flip the 3 and the 5, you get 5 and 3. If you put a negative in front of negative 2, you get 2. A negative of 4 is negative 4. That wasn't hard. And that's divided by the determinant of the ABCD matrix. Now, if you happen to mess up and instead take the determinant of this matrix that you just got when you flipped it, it wouldn't make any difference. You'd get the same thing. The determinant of this matrix is the same as the determinant. The determinant of this matrix is the same as the determinant of this. Because flipping the diagonal makes no difference in the product of those two numbers. And multiplying both of these numbers by -1 makes no difference in their product. So you might want to try to understand that, but it's not essential. Okay. The determinant then of the 3, -2, 4, 5 is what? Well, I've defined it up here, talked about it. It's this times this minus this times this. Okay, well, 3 times 5, yeah, there it is, 3 times 5 minus this times this. That's -2 times 4, right? Well, you can do the arithmetic, you know. This is going to be a -8, but minus -8 is +8. Add that to 3 times 5, you get 23. So now we have this matrix divided by 23. Now, since matrices have properties that you aren't completely comfortable with at this point, or probably aren't, I wouldn't be, until I've done, 30 or 40, 50 matrix calculations, and you should have done that by now, incidentally. It's not entirely clear how you divide a matrix by a number. I mean, I told you can't divide by a matrix, so why should you be able to divide a matrix by a number? Well, I'm not going to explain that to you. I'm just going to say that you can. And what you do is obvious. You can't do the inverse of a matrix by doing the inverse of every element, but you can divide a matrix by dividing every element by that number. Okay? So, when I divide the matrix by 23, I get 5 over 23, 2 over 23, -4 over 23 here, and 3 over 23 here. And there's my inverse matrix. So now we're prepared to take this step. Okay, well, that's probably enough to saturate you for a minute. Process that, and then it can move on.